We've looked at one-dimensional geometric figures, and in this lesson we'll be looking at the two-dimensional geometric figures. And I think the two-dimensional geometric figures might be more familiar to you since they are more easily seen in real life. Just as a quick review, let me go over the one-dimensional figures that we've learned. So that was called a point. This is the most basic component. If you line up a lot of points like this, it becomes a line segment. And if a line segment goes on forever in both directions, it's called a line. If a line segment only goes forever in one direction, it's called a ray. And if you join two rays together, it became an angle. And then it's a special kind of angle where you can fit a little square in between. It's a right angle. Then we had two lines that cross each other, which are called intersecting lines. Two lines that intersect at right angles, which are called perpendicular lines. And two lines that never cross each other, like that, are called parallel lines. And these are, or not all of these, but some of these are going to be important in defining some of our two-dimensional geometric figures. Okay, so for two-dimensional geometric figures, I'm going to start with the broad category and then I'm going to go into the more specific. So in the broad category, we have what's called the simple closed curve. So by closed curve, by closed, we mean that the starting point of the figure and the ending point of the figure are the same. So for example, I have something like this. I'm drawing a figure and it has to end at the same place. Right? I've started here and I'm ending here. So that's what we mean by closed. And the shape that it encloses, this would be the simple closed curve. If I had something like this, and then it ends here, this one started here but ended here, so this is not a closed curve. Okay? And what I mean by simple, is that even if I started and I'm ending at the same point, I can't cross. So I've started here and I'm ending here, but I've crossed the point, or I've crossed the sides of the curve right there. Right? So this is not a simple closed curve. This is also not a simple closed curve. Okay, but this is a simple closed curve. So to be a simple closed curve, it has to start and end at the same place, and it can't intersect like this. Okay, and just to, while I'm at the simple closed curve, I want to also show you the difference between one-dimensional and two-dimensional figures. So this is two-dimensional, right here. A line segment is one-dimensional. So one dimension means if I'm inside that figure, so I'm inside right there, I'm a little point inside the line segment, and I want to move along the line segment, I can only move forwards and backwards like this, right? I can only move along that line segment. The same with lines. I can only move this way and that way, forwards and backwards. Same with rays. I can only move forwards and backwards. But if I'm inside a two-dimensional figure, so this simple closed curve, if I'm inside there, I can move forward, I can move backwards, but I can also move up and down. I can move in 4 directions, and I can even actually move in a combination of some of these directions. I can move like diagonally, like this way. So this is the difference between one dimensions and 2 dimensions. So 2 dimensions, we have another direction that we can move to. We can move up and down in 2 dimensions. Okay, so inside the simple closed curve category, we have what's called polygons. Now, polygons are simple closed curves, but they are made of line segments. So again, remember that by simple closed curve, I mean that we have to start and end at the same point, and it can't intersect each other. And it's made of line segments. Remember, this is our line segment right here. This is our line segment. And line segment looks like this. So I have to make a simple closed curve out of line segments. I can go like that. I can put another line segment like this. And then I can put another line segment like that. So this one started here and ended here. And it doesn't intersect each other. So this is a simple closed curve, or this is a polygon. However, if I do something like this, this starts here, ends here, but it crosses in between here. So this is not, we can't consider this as a polygon because it's not a simple closed curve. It intersected with itself in the middle. But if we have other shapes like this is a polygon because it starts and ends at the same point and it doesn't intersect itself. So this is okay. Okay, so these are what's called polygons. They have line segments, or they are made up of line segments. So this right here, even this is a simple closed curve, this is not a polygon because the sides that we've used to make the figure are not line segments. So these are not a polygon and not a polygon. Now inside the category of polygons, we have what's called triangles. And I'm sure you've heard of the word triangles before. The word, or the prefix tri means 3. So triangles are polygons with 3 sides. With 3 sides. So I've drawn a triangle up here. This is a kind of triangle. It has 3 sides, 1, 2, and 3. You can also draw other types of triangles like this. It's a triangle. 1, 2, 3 sides. This is also a triangle. 1, 2, 3 sides. So by triangles we mean polygons with 3 sides. And this one, I don't think you're familiar with the name. It's called quadrilaterals. Quadrilaterals, and these are polygons with 4 sides. Now, even though you haven't heard of the word quadrilaterals before, I'm sure you've seen some types of quadrilaterals. So beginning with what's called a parallelogram. This is a parallelogram. Parallelogram. And why is it called parallelogram? Because if you look at the shape, this side and that side are parallel. The red sides are parallel. And remember, parallel lines, we mean that the two sides are never going to meet, even if we extend those. So even if we extend these sides like this, it's never going to touch the bottom side. And the same thing can be said with the other pair, this pair right here, the blue sides. If you extend the blue sides are never going to touch each other. So this is what we mean by parallelogram. The two sides, or the two pairs of sides, are parallel to each other. The blue is parallel with the blue, and the red is parallel with the red. Now, a special kind of parallelogram is a special kind of parallelogram where all of its angles are right angles. Remember, we looked at right angles right there. So this right here is also a parallelogram because this side and that side are parallel, and also this side and this side are parallel. But it's a special kind of parallelogram because its angles are all 90 degrees. And this is called a rectangle. I'm sure you've heard of rectangles before. This is called a rectangle. And for a rectangle, if all the sides of a rectangle are equal. So this is a rectangle where all of its sides are equal. And that's equal to that, and that's equal to that. So now this is called a square. And I'm sure you've heard of squares before as well. And similarly, rectangles or squares are a version of rectangles where all of its sides are the same. We have a similar shape for parallelograms. A parallelogram where all of its sides are the same, something that looks like that. Now, for this shape, the angles don't necessarily have to be right angles because it's not a rectangle or a square. This is called a rhombus. It's a special kind of parallelogram where all of its sides are the same. So the rhombus and parallelogram are to each other as a rectangle is to a square. Okay, and we have one last shape that I would like to look at. Now this is a shape, or this is a quadrilateral where only one of its pairs of sides are parallel. So this shape right here, this side and this side are parallel, but this side and that side are not parallel, because if you extend this line like this, extend this line like this, they're going to meet right there. So this is not a parallelogram. Only one of its pairs are parallel, and this is called a trapezoid. Trapezoid. And trapezoids can actually come in other forms as well. So this is one kind of trapezoid right here. Another kind of trapezoid looks like this. This is also a trapezoid because these sides are parallel, but the blue sides are not parallel. If you extend these, they're going to meet here. Okay, so this is another kind of trapezoid. So now these are all kinds of quadrilaterals right here. Quadrilateral again means polygon with 4 sides. And again, same as the one-dimensional shapes. Just try to be familiar with the shapes and the names of those shapes for the 2 dimensions. I can't actually fit all this in one screen. But just remember the definitions, especially for the more common shapes, and be familiar with how each of these shapes look like.